Hi students, welcome to the ACE online platform. So here we're going to focus on this numerical answer type question and multiple select questions. Fine. And this is a session which is targeted for ECE students who are preparing for the GATE 2026. Fine. So we'll directly dive into the questions. Fine. So let me check out how many students are active. Okay guys. Fine. So let us proceed here. Fine. So as I said earlier, so we're going to deal with electromagnetic theory. Electromagnetic theory is an important subject for the EC students and it plays a major role in your selection process. Fine. So let us take up these questions here. So I have not taken the questions here according to the flow of the syllabus. So I have jumbled them. So I have taken the questions here. Ultimately, numerical answer type questions and multiple select questions. Here is a question, guys. An antenna has the average radiation intensity of U average is equal to 4 by pi. If the efficiency of the antenna is 60%, then the input power is dash watts. So it is a purely formula based question. Fine. So what is the U average? The U average by definition is power radiated by 4 pi. So which is equal to 4 by pi. So this implies the power radiated is equal to 16. Fine, watts, 16 watts. And what is this eta? By definition, it is a power radiated by power which is supplied to the antenna. So which is 0.6. From here, he is asking us to find out what is the input power, Wi. So Wi is equal to Wr divided by 0.6. It is 16 divided by 0.6. So check out this value, 16 divided by 0.6. It is 26.66. So keep commenting your answers. Fine. So it is yes. This one is 26.66 watts is the answer. It is a numerical answer type question. So it is asking answer in the watts. It is 26.66 is the answer. Done? Yes guys, are you all with me? Just raise your hands, just keep posting your answers. Yes, 26.66. Yeah, you are correct, Aman. Okay, done. Let us have one more question here. So this question is related to the uniform plane wave in the arbitrary direction. Here it is a numerical answer type question. The electric field of an EM wave traveling in the free space. So it is traveling in the free space is given by this one. So the E is equal to 5 I cap plus 2.5 Z cap into cos omega t plus Y minus 2Z volt per meter. So then the wavelength lambda of the wave is. So it is asking for the wavelength. Fine. So this entire thing can be written. That means the wave is traveling. You can observe here. So the wave variable is dependent on the Y and Z. That means the wave is traveling in the YZ plane. Fine. And X is missing. So what is the observation you can make here? The wave is making 90 degrees with the X axis. Anyhow. So here you can write this entire thing as a E naught. Just I don't want to repeat the things here. So I'll going to write E is equal to E naught into cos. So I'll going to split this one as a dot product of two vectors. So how that can be written? It is omega t minus y minus y cap plus 2 z cap dot product with y cap plus z cap. You can make a comparison. See, all the negatives must be given to this one. it must be maintained. This is a position vector. So in our analysis, if you go back and check out your analysis, so in the analysis, all the angles are defined with respect to the positive x-axis, positive y-axis, positive z-axis. That means in the first octant. So this position vector must be maintained positive. All the negative must be given to this vector. So what is this vector? It is a wave vector k. So which is equal to minus y cap plus 2z cap. It is asking the wavelength. Let us find out what is called a beta. What is the beta? It is the magnitude of k is nothing but a beta, which is equal to square root of minus 1 square plus 2 square, which is equal to square root of 5, which is equal to 2 pi by lambda. Fine. So here lambda is equal to 2 pi divided by square root of 5. So how much is this, guys? What is this value? Let me check out. 2 pi divided by square root of 5. Yes, friends, what is the answer for this? Two pi divided by square root of 5. 2 into pi divided by 2.8 meters. Am I correct? So 2.8 is the answer for this. Clear, guys? Fine. Let us proceed further. So keep commenting your answers. Fine. 2.8. Correct. Let us have one more question. Here is a question. This question is something you need to think about it. This question is, it is in comparison with rectangular waveguide and circular waveguide. So in our GATE syllabus, the circular waveguide was introduced in the year 2020, in the syllabus year 2020. But right from the inception, there was not even a single question from the circular waveguide. Okay. If at all, if you wanted to frame a question, he will frame on the cutoff frequency of the circular waveguide. Anyhow, guys. So something I have framed the question related MSQ question on the circular waveguide and rectangular waveguide in a comparison of circular and rectangular waveguide. Okay. So let us try to address this question here. So yes. So the following inferences can be drawn in comparison of the circular and rectangular waveguide. In bracket, something is written at a same cutoff frequency for dominant mode. What is the first one? So if you wanted to maintain the same cutoff frequency in the rectangular waveguide and circular waveguide, some of the inferences which can be drawn. Dominant region rectangular waveguide is lower than the circular waveguide. Broad dimension of the rectangular waveguide is equal to 2 times the radius of the circular waveguide. Option C, broad dimension of the rectangular waveguide is equal to 3 times the radius of the circular waveguide. Fine. The other one is dominant region rectangular waveguide is higher than the circular waveguide. Fine. So little bit you need to think about that. So what it is said in the question is, so we wanted to maintain the same dominant mode, same cutoff frequency for rectangular waveguide and circular waveguide. So what is the dominant mode in the rectangular waveguide? It is FC TE 10, which is equal to 1 divided by 2 square root of mu epsilon into 1 by A. I want to make this one equal to, because that is what given in the question. For the circular waveguide, what is the dominant mode? FC, it is TE 11, which is equal to 1 divided by 2 pi square root of mu epsilon 1.841 divided by pi, not pi, it is r. So we wanted to maintain the same dominant mode cutoff frequency is same in that one and this one. If that is the case, he is asking the relation between A and R. Okay. So you observe the options here. Broader dimension of the rectangular waveguide is 2 times the radius of the circular waveguide. Okay, guys. Fine. So now what we are going to do here what we are going to do, let us make a comparison here. So we can cancel out the things here. So this is 1 by 2 root mu epsilon, 1 by 2 root mu epsilon you can cancel out. So you are going to get 1 by A. What it is? 1 by A is equal to 1.841 divided by pi into R. Yes. So what happens to this A? A is equal to pi R divided by 1.841. So what is the pi divided by 1.841? What is its value? Pi divided by 1.841. Yes, guys. Pi divided by 1.841. So it is 1.706 R. So approximately A is equal to 2 into R. So broader dimension of the rectangular waveguide is equal to 2 times the radius of the circular waveguide. Fine. So remember, this is only true when you wanted to maintain the same cutoff frequency. So what is the observation? Broad dimension of the rectangular waveguide is 2 times the. Option B is the answer. Fine. And is also making some other conclusion. What is that? Dominant region in the rectangular waveguide is lower than the circular waveguide. He is giving some general statement. Dominant region in the rectangular waveguide is higher than the circular waveguide. Let us see. Let me turn the page here. So let us try to find out. Let me turn the page here. So what is the dominant region in the rectangular waveguide? What is the dominant region? The range of frequencies from first to next. Suppose if B is less than or equal to A by 2. So FC TE 10 is less than, F is less than FC TE 20. What is the dominant region width? Delta F is equal to FC TE 20 minus FC TE 10. If you subtract these two things, so delta F is equal to 1 divided by 2 square root of mu epsilon. Mu epsilon is equal into 2 by A. 1 minus 2 square root of mu epsilon, it is 1 by A. Okay. So delta F is equal to, this is 1 divided by 2 square root of mu epsilon, it is 1 by A. This is nothing but FC TE 10. That means dominant region width is equal to cutoff frequency of the dominant mode. This is for the rectangular waveguide. Okay. Let us try the dominant region width for the circular waveguide so that we can make a comparison. So for the circular waveguide, what is the dominant region width? FC TE 11 is less than F is less than FC TM 01. So this is delta F is equal to FC TM 01 minus FC TE 11. So you can write this one as 1 divided by 2 pi square root of mu epsilon 2.405 divided by R minus 1 divided by 2 pi square root of mu epsilon 1.841 divided by R. Okay. You can check out this one. 1 divided by 2 pi square root of mu epsilon into 1.841 divided by R into 1 by 3. You can check out. So this is nothing but a dominant mode. Delta F is equal to, actually this is a FC, you can take this as a theory question, into 1 by 3. Okay, so just we are making a comparison here. So here the dominant region width in the rectangular waveguide is exactly equal to cutoff frequency of the dominant mode. So what is the dominant region width in the circular waveguide is equal to 1/3 times the cutoff frequency of the dominant mode. So that means the dominant region width in the circular waveguide is less compared to the dominant region width in the rectangular waveguide. Fine. So that is how you can make a comparison. So dominant region width, dominant region in a rectangular waveguide is lower than the circular waveguide. So this is correct. Broader dimension, this is wrong. This is dominant region rectangular waveguide is higher than the circular waveguide. It is a wrong. Fine. So it is MSQ. Clear, guys? So how many questions we have done here? So it is a new NAT. It is a MSQ. Fine. So let us explore some more concepts here. Yes. So here it is a numerical answer type question. So the questions on Gauss law, questions on Ampere's law is a very popular. Okay. So there will be one question from the Maxwell's equations. So very important is a Gauss law and Ampere's law. So in the differential form or integral form. So here I have framed the question, numerical answer type question on the Gauss law. Clear, guys? So shall we handle this question? Yes. Yes, keep answering your questions. So yes, so how to handle this question? You have to handle this question in two steps. First, you need to find out the charge density, then total charge. You can do purely mathematically. Yes, you can make use of what is called a Gauss law. If a displacement flux density d is equal to 2 sin theta by r cap coulomb per meter square, then the total charge enclosed by the sphere of radius 2 meters is obviously centered at origin. Okay, so first find out the volume charge. What is the volume charge, guys? The rho v is equal to divergence of d. So this is having only r component. So what happens to this one? It is 1 by r square sin theta dou by dou r square sin theta into dr. Okay, remaining terms are 0. Just substitute there. So what you are going to get? It is 1 divided by r square sin theta dou by dou r square sin theta into what is this dr? It is 2 sin theta by r. You can bring the constants outside. It is 2 sin square theta divided by r square sin theta. So it is r square divided by r. It is r differentiation is 1. So this one is 2 sin theta by r is rho v. Units are coulomb per meter cube. Once you got a volume charge, you can find out the total charge by performing the volume integral. Okay, so that you can handle in 2 steps. Clear, guys? I'll going to turn the page here. So what is the total charge here? The Q is equal to the volume integral of rho v into dv. So what is this rho v? It is 2 sin theta by r into differential volume. For the spherical coordinate system, the differential volume is, it is r square sin theta dr d theta d phi. So bring the constant outside and separate out the variables here. So it is 2 into r dr, it is sin square theta into d theta, and this is d phi. Clear, guys? Okay, so this one is 2 into r square by 2, r limits are from 0 to 2. So it is minus. So what is the integration of this part? Let me do this integration of this part separately. I am going to call this as I. So what is the integral of I? It is sin square theta d theta, which is 1 minus cos 2 theta by 2 into d theta. So this is 1 by 2 into theta. It is minus sin 2 theta by 2, where theta is from 0 to 5. Yes. upper limit minus lower limit. We'll come to that. So if I substitute upper limit minus lower limit, I'll going to get pi by 2. All the lower limits will be 0. Fine. So come back here. So it is 2 into r square by 2. This is from 0 to 2. So this value is pi by 2. This integral is phi, and phi here, the phi integral is from 0 to 2 pi. Upper limit minus lower limit, it is 2 square into pi by 2 into 2 pi. So this 2 will go, it is 4 into pi square, approximately 40. 39 point, how much? Yes guys, 39.47 coulombs. It is a numerical answer type question. Okay guys, fine. Direct, it is a Gauss law. Questions on Gauss law is a very popular. Fine. So let us proceed further. Here is a question, one more numerical answer type question. It is on the power calculations. So it is a general question, general electromagnetic theory question, but it is framed in the context of antenna. Okay. So an antenna is located at the origin, has a far zone electric field E theta is equal to sin theta by r e to the power of minus j beta r volt per meter. The total power radiated in the free space is. You have to answer this question in the 2 steps. First step, you need to find out the power density, then total power. Fine. So how do you find out the power density? So the P average, what is the formula? P average is equal to E magnitude square divided by 2 into eta naught into r cap. Why? Because the wave is traveling in the free space. That is the reason why eta naught. Okay, you can substitute everything here. 1 divided by 2 into eta naught. So what is the E magnitude? It is sin square theta divided by r square. Just you need to take only its magnitude into r cap. This is the power density, but we need a total power W average. W average is equal to closed surface integral of P average. This is having only r component. So it is, you will going to get r square, differential area r square sin theta d theta d phi r cap. Okay, that is in the theta phi plane. Just substitute here. So this is sin square theta divided by 2 into eta naught into r square into r cap dot r square sin theta d theta d phi r cap. I will going to turn the page here. So bring the constant outside. 1 divided by 2 into eta naught outside. So this r square will go. What you will be left with? It is sin cube theta into d theta d phi. So you need to perform this integral. 1 divided by 2 into eta naught into sin cube theta d theta d phi. So I will going to take up this integral separately. This integral, let me call this as I1, this is the integral I2. So what is the integral I2 here? Integral I2 is equal to, it is a d phi. So the phi limits are from 0 to 2 pi. So it is 2 phi, simple. Then how do you perform? There are different ways of performing the integral. So I will going to choose this technique. You can use the gamma function from your mathematics, which will going to save the time, or we can use sin 3 theta, which is equal to 3 sin theta minus 4 sin cube theta. But I will going to go in other way. How? I will going to write this sin cube theta as a sin square theta into sin theta. Sin square theta can be written as 1 minus cos square theta. So it is 1 minus cos square theta into sin theta into d theta. So this one is sin theta minus cos square theta into sin theta into d theta. So this one is minus cos theta plus cos to the power of theta by 3, where theta is ranging from 0 to 5. Substitute upper limit minus lower limit. So it is upper limit minus lower limit, it is 1 minus 1 by 3 minus 1 plus 1 by 3. So you can check out, this will be, this is 2 minus 2 by 3, which is 4 by 3. So you got all the values, just substitute there in the integral. So you are going to get the total power radiated from the antenna. So what is this W average here, which is 1 divided by 2 into eta naught into I1. What is I1? I1 is 4 by 3 into I2 is 2 pi. So this is 8 pi divided by 2 into 120 pi into 3. So in the question is asking the answer in milliwatts. So get the answer in milliwatts. Yes, let me check out. What is the answer, guys? It is 8 divided by 240 divided by 3 into 1000. So it is 11.11%. Yes, not percent, 11.11 milliwatts. Okay, it is a numerical answer type question. Yes, so 11.11 is asking in terms of the milliwatts. Okay, let us proceed further. Yes, so it is a MSQ question. Read the question carefully. A uniform plane wave propagating in the free space is characterized by the following expression. So this is how the wave is traveling. The wave is traveling in the positive z direction and it is oriented in the y. So the P, and this one is a beta. Beta is 1.5 in 1.571. Okay, and this is the peak amplitude of the traveling wave, 1.5. It is incident normally, okay, upon a semi-infinite lossless non-magnetic. It is a lossless, that too non-magnetic medium having epsilon r is equal to 6.25. Okay, which of the following statements are correct? Are correct. There are multiple answers, multiple select question. Okay, guys, let me turn the page here. So let us draw some rough diagram here. So the wave is traveling in the free space whose parameters are mu naught epsilon naught. Here in the medium 2, mu naught epsilon r, and epsilon r value is given as, it is 6.25. So as we all know, what is this eta 1? Eta 1 is equal to square root of mu naught by epsilon naught, which is 120 pi. What is this eta 2? Eta 2 is equal to square root of mu naught by epsilon naught epsilon r, which is 120 divided by square root of 6.25. So you can check out this value. It is a 48 pi. So go back here, 48 pi ohms. So option A will be the correct answer. Next, the reflection coefficient is minus 0.43. Check out what is the reflection coefficient for the normal incidence. Gamma is equal to eta 2 minus eta 1 divided by eta 2 plus eta 1, which is 48 pi minus 120 pi. 48 pi plus 120 pi. So check out this one. So the gamma will be equal to, so my calculator is showing, so the gamma is minus 0.43. Minus 0.43. Go back. Minus 0.43. Yes, this is also correct. Third one, the amplitude of the reflected electric field is, incident is 1.5, is asking what is the reflected. So let us calculate that also. So by definition, what is the reflection coefficient? Gamma is equal to a reflected electric field by incident electric field, which is minus 0.43. So is asking for what is the reflected. It is minus 0.43 into incident is 1.5. Okay, so you can just multiply here. So here my calculator is showing its value as minus 0.643 volt per meter. Is that correct? Check out. Minus 0.643. Minus 0.643. Correct. The reflection coefficient is minus 0.7. So this is wrong. So A, B, C are correct. It is the MSQ. Clear, guys? Let us proceed further. Here is a question. Yes. Something interesting. So it is related to the antenna arrays. That too, image theory is involved here. A Hertz dipole is vertically mounted at an height of lambda above an ideal conducting ground. Options are given. The direction of maximum radiation is 90 degrees with respect to the orientation of the antenna. Option B, the direction of null is 0 degrees with respect to the orientation of antenna. Option C, the direction of null is 75.72 degrees with respect to the orientation of the antenna. Option D, the direction of null is 41.4 degrees with respect to the orientation of the antenna. So it is a MSQ question. Okay guys, fine. Let me turn the page here. So what is given in the question? So there is a Hertz dipole. So there is a perfectly conducting ground. Antenna is placed vertically. What is the height from here to here? The height from here to here is a lambda. So here conductivity tends to infinity. So as it is a perfectly conducting ground, conductor, infinity conducting, yes, perfectly conducting in the sense ideal conducting, conductivity tends to infinity. So this will going to act like a mirror. So what we can do, image theory, from the image theory, you can just remove this perfectly conducting ground, and instead of that you can place one more antenna. So this is from the image theory concept. So this is the axis of the array. This is the orientation of the antenna. Yes guys. So this is a orientation of the antenna. So how the angle is defined like this. This is theta. This is also theta. This is angle made with respect to the orientation of the antenna. And this is also equal to phi. What is the phi? It is the angle made with respect to the axis of the array. Okay. So when the antennas are placed vertically, so the phase difference between the array antennas is 0. There is no phase difference. So here lambda, one more lambda, the total distance is 2 lambda. This is from the image theory. We're going to analyze this one by taking the two antennas, but remember the radiation happens only above the ground. You have to discard whatever you will get below this one. Just for the analysis purpose, we will take the two antennas. Now it is a two element array. Yes. So what is the two element array? What are the conclusions we know for the two element array? It is F total is equal to a unit pattern into group pattern. What is the unit pattern? It is a Hertz dipole. So the normalized radiation pattern is sin theta. You have to remember this. For the Hertz dipole, normalized radiation pattern or unit pattern is sin theta. For dipole antenna, cos beta h cos theta minus cos beta h by sin theta. Okay. Then what happens to the group pattern? The group pattern is equal to cos psi by 2. What is this psi? It is delta plus beta d cos phi. What is this delta? A delta is there is no phase difference between these two things, plus a 2 pi by lambda into what is the spacing between these two things is 2 lambda into cos phi. So it is 4 pi cos phi. Bring everything and substitute here. So what is the total radiation pattern? F total is equal to sin theta into cos psi by 2. It is 4 pi cos pi by 2. F total is equal to, it is sin theta into cos 2 pi into cos phi. Here theta is equal to phi. The angle made with respect to the orientation of the antenna and angle made with respect to the axis of the array are same. So theta is equal to phi. Okay, done. So when do you get? Just go by the try. Okay guys, there was a small technical issue, no issue, fine. Observe here. So the null, one of the null is at 0, sin theta n is equal to 0. So the 0. The other one is it must be 0, we'll come to that point. So one of the null in the radiation pattern happens, the direction of null is 0 with respect to the orientation of the antenna, correct. These are correct. So there are other nulls also possible. Let us try to explore them. I'll going to turn the page here. So I'll going to turn the page here. What is the condition for the null, guys? So it is cos 2 pi cos theta n is equal to 0. Okay, this happens when 2 pi into cos theta n is equal to plus or minus 2m plus 1 pi by 2. So from here cos theta n is equal to plus or minus, it is 2m plus 1 divided by 4. So there are different possibilities are there. I can take m is equal to 0. So cos theta n is equal to plus or minus 1 by 4. So there are two possibilities here. Cos theta n is equal to, check out what is the cos inverse of 1 by 4 is 75.52 degrees. My calculator is showing. The other one is cos inverse of minus 1 by 4. Cos inverse of minus 1 by 4 is 104. 104.47 degrees. The other one is m is equal to 1. If I take m is equal to 1, cos theta n is equal to plus or minus 3 by 4. Cos theta n is equal to, it is 41.4 degrees. The other one is cos inverse of 3 by 4, it is 138.59. See here, the radiation happens only in the half of the plane. Why? Because the antenna is placed on the ground, perfectly conducting ground. We have incorporated one more antenna just for the analysis purpose. But you can treat this as a only half of the plane. The radiation happens only in the semi-infinite plane. So you can discard two of the, that means the range is only from 0 to 90. The remaining angles you can discard. You can discard this angle, you can discard this angle. So here is a null, here is a null. So that means what I mean to say is actual radiation happens only from here to here, 0 to 90. From 90 to 180 there is nothing. There is a perfectly conducting medium. Okay. So yes, we got 75.52 degrees and 41.4 degrees. So this is correct. This is also correct. Clear guys? Done. So let us proceed further. Here is a one more question related to the waveguides. Yes, you are correct, Aman. A, B, C, D. So 6 gigahertz signal is to be propagated in the dominant mode in the rectangular waveguide. Its group velocity is 90% of the free space velocity of the light. Then MSQ question it is. So you need to draw some observations here. So what is given in the question? The group velocity is 90% of the intrinsic velocity or velocity of the wave in the free space. Clear guys? So what is the group velocity formula? It is group velocity is equal to V naught into square root of 1 minus Fc by F whole square. It is the high pass filter term. So it is 0.9 of V naught. It is V naught square root of 1 minus Fc by F whole square. Clear? So what is the high pass filter term? We got 1 minus Fc by F whole square is equal to 0.9. Correct? What is the first part of the question? Is asking us for the guided wavelength. So what is the guided wavelength formula? Lambda bar is equal to lambda divided by square root of 1 minus Fc by F whole square. So which is equal to C by F divided by 0.9. Done? So it is 3 into 10 to the power of 8 divided by what is the operating frequency? It is a 6 gigahertz. 6 into 10 to the power of 9 divided by 0.9. So check out this value, guys. I think it is 5.5 centimeters. Yes, am I correct with algebra? So it is option A is the correct. Next, wave number inside the waveguide is, what is the wave number? The phase constant is also called the wave number. So it is the beta bar. So the beta bar is equal to 2 pi by lambda bar, which is 2 pi divided by 5.5 into 10 to the power of minus 2. So my calculator is showing its value as 114.23 radian per meter. Yes, guys. So it is 114. So yes, this is also correct. Next, the phase velocity is 3 into 10 to the power of 8 meters per second. It is wrong directly, one can say. So that because intrinsic velocity is 3 into 10 to the power of 8, group velocity is there, the phase velocity will be different. Directly you can say that this is a wrong one, or even you can cross check with the formula. What is the formula, guys? So the phase velocity is equal to intrinsic velocity divided by group velocity. Yes. So it is V naught square divided by, it is 0.9 into V naught, which is V naught will go, which is 3 into 10 to the power of 8 by 0.9, obviously, which is not equal to 3 into 10 to the power of 8. So option C is wrong. Next, the signal wavelength is 5.5. No, it is wrong. What is the signal wavelength, guys? The lambda is equal to C by F. So which is 3 into 10 to the power of 8 divided by, what is the operating frequency? It is 6 into 10 to the power of 9, it is 0.5. 0.5, yes, 0.5 into 10 to the power of minus 1. This is 5 centimeters actually, he said 5.5, so it is wrong. Option A and B are correct. MSQ again. Okay, guys. Okay, let us proceed further. So let us take up some more questions. This is related to the antenna radiation, and this is related to the waveguides, and this is related to the transmission lines. So let us take up 3 more questions here. It is a MSQ again. So the antenna, an antenna is fed with the 100 watts of power. The efficiency of the antenna is 80%. If the power radiation intensity, power radiation pattern of the antenna is, see here, generally the radiation pattern is defined for the electric field, normalized radiation pattern, isn't it? But here it is defined for the power. Okay, no issue. And the 0 elsewhere. So what is the, he has drawn some observations here. The power radiated by the antenna is 80 watts. Let us check. The first one, what is the efficiency? Power radiated divided by power which is supplied, which is given as a 80%. Am I correct? Yes, 80%. And is asking what is the power radiated, which is 0.8 into what is the power supplied to the antenna, is 100 watts. So power radiated is 80 watts. So here it is correct. Power radiated is 80 watts. Next is asking for the directivity. So what is the directivity, guys? Directivity formula is 4 pi divided by theta phi f of theta comma square sin theta d theta d phi. See here, f of theta comma phi is a normalized radiation pattern. Square of that one is a power radiation pattern. So directly has given the square value. This entire thing is nothing but a power radiation pattern, because squaring is there. So it's p of theta comma phi, if you want to say. Of course, it is only dependent. It is dependent on the theta and phi. You should have some theta comma phi here. So anyhow, so you can substitute here and perform the integration. That's all it is. So let me do that. So what is the directivity D? Directivity D is equal to 4 pi divided by theta and then phi. F of theta comma phi whole square is given. It is a sin square theta sin square phi. So it is a sin square theta sin square phi, sin theta in the formula d theta d phi. Okay, so this is 4 pi, it is theta, it is phi. So it is a sin cube theta sin square phi d theta d phi. Separate out the variables here. So it is a 4 pi divided by sine cube theta d theta, it is sine square phi d phi. So how do you make this integration? Anyhow, theta limits are from 0 to phi only. So it is a 4 by 3. In the previous question we have done that one. Integral is from 0 to, let me show you. Integral is from, what is this value? Integral from 0 to pi sine cube theta, it is 4 by 3. So I will make use of that, but you need to do in the exam, isn't it? So what I mean to say here is, what is this value? It is a 4 by 3. Let me turn the page here. So I am calling this as a integral I1. This is integral I2. Let me turn the page here. So what is the integral I1, guys? So the integral I1 is equal to theta. Theta is from 0 to phi. It is sine cube theta d theta, which is 4 by 3. Correct? So what is the integral I2? It is a phi. Sine square phi d phi. This can be written as 1 minus cos 2 phi divided by 2 into d theta d phi. So it is a 1 by 2. It is a phi minus sine 2 phi divided by 2. Phi is from 0 to phi. Substitute upper limit minus lower limit. It is pi by 2. It is a I2. So substitute everything there, you will going to get the directivity. So what is the directivity, guys? D is equal to 4 pi divided by I1 into I2. What is I1? It is a 4 by 3. I2 is pi by 2. So it is a 6. Am I correct? Yes, guys? It is a 6. Am I correct? Yes. So it is a 4 pi divided by, it is a 4 by 3 into pi by 2. So this is a 6. Correct? Fine. So once you got this directivity, what it is mentioned in the question, directivity is 12. It is wrong. Directivity is 6. The maximum radiation intensity is 76.39 watts per steradian. Maximum radiation intensity. What is the maximum radiation intensity? From the directivity you will get. So it is U max divided by U average. Yes. So what is the U average? Did you get the U average from the first part of the question? Any U average for information given in the question? Maximum radiation intensity. Yes. So you can find out the U average. What is the U average, guys? It is U max divided by power radiated by 4 pi. So from here you can find out the U max. What is this U max? D into WR divided by 4 pi. So what is the directivity? 6 into, what is the power radiated from the first part of the question? Power radiated, total power radiated is 80 divided by 4 pi. Correct, guys? So this is 6 into 80 divided by 4 divided by pi. So it is 38.19 watts, not watts, it is the watts per steradian. So what is given in the question is, it is something different, 76. So it is wrong. Next, power density along the direction of the maximum radiation is power density. Let us take the power density. How do you find out the power density? Power density and power intensity. So maximum power density is asking. So what is the power intensity, guys? It is power density into R square. So from here you can find out the power intensity. Power intensity is equal to, power density is equal to power intensity by R square. So which is 38.19 divided by, at what distance he is asking? At a distance of, did he mention any distance in the question? So he has just said, he has not mentioned any distance here. So the distance is required here. So distance is required. So where is the distance here? So the no distance here. So we cannot answer this one. The power density along the direction of maximum radiation intensity is this one. For that, distance is required. So you cannot answer that. Yes. Distance is not given in the question. Why? Because we need a distance to find out the intensity. So the data given is insufficient. So you cannot comment anything on that. So you can comment only on the option A. Okay, fine. Anyhow, let us proceed further. So here is a one more question. It is a numerical answer type question, NAT. So inside an air filled waveguide, the total magnetic field is given by this one. So the extra magnetic field is given. So it is a TE wave. Okay. Anyhow, and the frequency of the wave is 2 gigahertz. Then the question is the cutoff frequency of the wave is. So it is asking for the cutoff frequency. You can go by the definition of the cutoff frequency. So for the TE wave, what happens? Ez is equal to 0 and Hz is not equal to 0. So you can notice this one is, we know that H square is equal to m pi by a whole square plus n pi by b whole square. You can notice there is a variation only along the x, that means only this one. So H is equal to, it is pi H square is equal to pi square. We have only one term is there. Okay, what is the cutoff frequency formula? It is 1 divided by 2 pi square root of mu epsilon into H. Okay, so here H is equal to pi. So you can just substitute here. So it is mu naught epsilon naught 3 into 10 to the power of 8 divided by 2 pi into pi. So it is 1.5 into 10 to the power of 8. So it is 0.15 into 10 to the power of 9 or 0.515 gigahertz is the answer. So what is the answer here? 0.15 gigahertz is the answer. It is a numerical answer type question. Clear, guys? Fine, done. Let us have one more question. Yes, this is related to the transmission lines. A 50 ohm lossless transmission line is connected to the load of 50 plus J 50 ohms. The maximum voltage measured on the line is 50 volts. Vmax is given. So the options are, it is MSQ again. So the magnitude of the reflection coefficient is, okay, the voltage standing wave ratio is, the power delivered to the load is, the peak voltage at the load is, okay. So the load value is given. First you need to find out, let us try to find out the reflection coefficient. What is the reflection coefficient at the load end? By the formula ZL minus Z0 by ZL plus Z0. So which is 50 plus J 50 minus 50 divided by 50 plus J 50 plus 50. You can check out this one. This will turn out to be, my calculator is showing it as a 9.55 watts. Clear? So this is correct. Next, option D. The peak voltage at the load is. So is asking what is the peak voltage at the load. So this is the power which is delivered to the load. Once you got that one, you can find out the peak voltage. I'm going to call this as a. Generally, how do you find out the power at the load? We need, for that we need a voltage at the load divided by 2 into RL. The load impedance ZL or RL. So from here, this we know that it is a 9.55. So it is VL magnitude square is equal to 9.55 into 2 into ZL. What is ZL here? The load impedance is this one. It's 50 plus J50. Just take up this magnitude here. It is the RL here. That is the resistive power, isn't it? So this is RL here. We are talking about the resistive power only. So it is a 50. So from here you can check out. Let me use my calculator here. So this is 9.55 into 2 into 50 square root of. So this one is square root of 955. It is square root of 955. Yes, it is 30.9. Yes, or simply 31. 30.9 volts. Go back to the options here. 30.9 volts. Yes. So option D is also correct. Okay, guys. So here in this short time, in this 1 hour of session, so I have tried my level best to show you the flavor of the numerical answer type questions and multiple select questions. Those are the new things, isn't it? Whatever the previous questions we have, they all are related to the multiple choice question or numerical answer type questions. So here in this process, we have explored some new concepts also. Now some new concepts, some new models also. Clear, guys? And in this one question, if the distance was mentioned, we can find out that. So let us incorporate the distance here. Let us say power density along the direction of the maximum radiation at 1 kilometer is. Okay, suppose if I include such a thing, so you can find out here. So it is 1 into 10 to the power of 3 whole square. So I'll go into, it is 38.19 divided by 10 to the power of 9. So it is 38 point. This one is 38.19 micro watts per meter square. 38.19. So obviously, which is not the answer. Okay, guys. Anyhow, so these are some of the models where you can connect yourself with your preparation. It will going to enhance your understanding, your preparation, and it will going to boost up, and it will going to speed up your preparation for your GATE exam. Fine. Hope you had a wonderful time. Keep learning, keep going, make a short notes, and take test series very seriously. Enroll into the ACE test series. Okay, take your preparation and test series very seriously. I'll wish you very success and happy new year in advance. All the best, and I wish you success in the upcoming year. Happy new year. Thank you. Good luck. All the best.